Imagine you're sitting on a jury. The prosecutor calls a forensic expert, white lab coat, serious voice. They say, "We tested the suspect's hands. Gunsmoke is present. That means they fired the gun." The room goes quiet. That sounds damning, almost undeniable. But here's the twist. In real forensic science, that single statement should never decide a person's fate. Gunshot residue, GSR, can travel, transfer, stick to innocent people, and vanish from guilty ones. It can be carried by police, by handcuffs, by car seats, even by a handshake. In this video, we're going to pull back the curtain on ballistics and tests for gunsmoke, revealing what they can actually prove, and, more importantly, what they absolutely cannot. By the end, you'll never hear the phrase gunsmoke test the same way again, and you'll be able to spot junk science the moment it appears in a courtroom drama. Before we start tearing apart myths, let's set the stage. Ballistics is the science of how firearms and ammunition behave, from the moment the trigger is pulled to where the bullet finally stops. TV shows simplify this into a magic box of answers, a single test that says who fired, from where, and when. Real life is slower, messier, and full of uncertainty. In this episode, we'll walk through what GSR actually is, how labs really test for gun smoke, why distance and direction are so tricky, and how courts sometimes misread the science. We'll also look at real cases where gun smoke evidence helped convict or exonerate defendants. If you're into true crime, law, or just demystifying complex science, stay with me until the end. And if you like this kind of deep dive, consider subscribing and tapping the notification bell so you don't miss the next investigation we break down here on the channel. Let's start with the gunsmoke itself. When a modern firearm is fired, the primer ignites, powder burns extremely rapidly, and gases explode down the barrel, pushing the bullet forward. That violent event produces a cloud of microscopic particles, burned and unburned powder, metals from the primer and cartridge, bits of lubricant, and other debris. Collectively, we call some of this gunshot residue, or GSR. It's not just smoke you see in the air. It's tiny, often invisible fragments, many smaller than the width of a human hair. These particles can land on hands, clothing, hair, nearby walls, even ceilings. But here's the key. That cloud doesn't politely fall straight down and stay put. It drifts, it bounces off surfaces, and it can hitchhike on anything that touches it afterward. GSR is real and detectable, but it's also mobile, fragile, and far from a perfect fingerprint of guilt. So what does a gunsmoke or GSR test actually look for? Traditionally, forensic labs used sticky stubs or swabs on a suspect's hands, clothing, or face, then examined them under scanning electron microscopes combined with X-ray analysis. They'd search for particles containing specific combinations of lead, barium, and antimony, classic signatures of many primers. More modern ammunition uses different heavy metals, and some labs have updated methods, but the logic is the same. Find microscopic particles that match what a fired cartridge typically spits out. The important part is this: the test detects particles, not actions. A positive finding means certain materials are present. It does not, by itself, tell you who fired the gun, when it was fired, how far away it was, or whether that person even held the weapon. The moment you jump from "these particles exist" to "this person is the shooter," you've already left solid science. Here's where things get dangerous in court. Many people, including some professionals, still treat a positive GSR result as a smoking gun. But scientifically, gunsmoke tests are far better at saying maybe than definitely. First, GSR can land on bystanders within several feet of a fired weapon. Second, it can travel by transfer. Someone sits in a police car where another suspect previously shed residue, or they're handcuffed with equipment contaminated from prior arrests. Third, modern environments contain GSR-like particles from fireworks, nail guns, and industrial tools. Even when the particles look classic, the timeline is fuzzy. GSR can start falling off within hours as people move, wash their hands, or rub against surfaces. A clean test doesn't prove someone didn't fire a gun. A positive test doesn't prove they did. Courts that treat Gunsmoke results as binary proof are misusing a nuanced, probabilistic tool. Let's talk about distance, the classic TV moment where an expert says, "The shot was fired from exactly 3.2 feet away." Real ballistics is rarely that precise. Investigators do distance determination by test firing the same weapon and ammunition at targets from known distances, then comparing the pattern of residue, stippling, and soot to the victim's clothing or skin. At close range, you might see dense GSR and burning. Farther out, just a sparsely scattered pattern. But human skin varies, fabrics react differently, and tiny changes in angle can alter the pattern. Wind, barriers, or obstructions can also disrupt residue. So while distance testing can often distinguish, say, a contact shot from a several-meter shot, it usually can't pin down inches. And Gunsmoke alone definitely can't tell you a precise distance on its own. Any expert claiming exact distances from GSR is stepping beyond what the data honestly supports. Angle and direction are another area where pop culture oversells what ballistics can do. Trajectory analysis, using bullet holes, entry and exit wounds, and sometimes rods or lasers, can give a general path. But Gunsmoke itself is a terrible compass. That cloud spreads roughly forward and outward from the muzzle. It doesn't leave a neat arrow pointing back at the shooter. On skin, stippling from unburned powder grains may suggest the direction of travel, but rotations, deflections off bone, or ricochets can complicate the picture. Inside cramped spaces, cars, hallways, small rooms, residue can bounce, swirl, and settle unpredictably on walls, seats, and passengers. So while investigators might reconstruct a likely shooter position using all available evidence, GSR alone can't tell whether someone was standing, crouching, or sitting, or whether a victim's arm was raised or lowered. Any narrative like that must be labeled as a hypothesis, not a proven fact. Contamination and secondary transfer are the silent killers of reliable GSR evidence. Picture the average arrest. Officers handle firearms, search vehicles, handcuff suspects, transport them in patrol cars, and process them in holding areas. Every one of those steps is an opportunity to move GSR from one surface to another. Studies have found GSR on police station chairs, patrol car seats, handcuffs, even on the uniforms of officers who regularly visit shooting ranges. If a suspect is swabbed after being placed in a contaminated environment, a positive test might say more about that environment than their actions. Even lab spaces can be problematic if strict protocols aren't followed. And it goes both ways. A genuinely armed suspect might end up testing negative because they washed, wore gloves, or fired a low-residue weapon. Good science acknowledges these possibilities up front. Bad science pretends they don't exist and sells certainty instead. Let's ground this in real-life stakes. Across the world, there have been cases where GSR played an outsized role in convictions later questioned or overturned. In some, defendants tested positive after simply being in the same car or room as a shooter. In others, experts overstated what residue could prove, telling juries that particles confirmed someone had fired a gun, when the data only supported possible contact. Innocent people have spent years in prison partly because courts treated Gunsmoke evidence as decisive. At the same time, there are cases where GSR truly helped exonerate someone, showing, for example, that a supposed execution-style murder was more consistent with a close-range suicide. The lesson isn't that GSR is useless. It's that the story, built on top of it, can be dangerously wrong when lawyers and experts confuse probability with certainty, or science with storytelling. Courts are slowly catching up to the limitations of forensic methods, including GSR. In some jurisdictions, judges now require that experts present Gunsmoke findings in cautious, probabilistic language consistent with, could be the result of, not proves. Appeals courts have criticized testimony that overstated the meaning of positive tests or ignored contamination risks. Professional organizations have also updated guidelines, stressing that GSR cannot identify a specific gun, cannot establish the exact time of firing,
and should never be the sole basis for determining who pulled the trigger. Defense attorneys increasingly bring in independent experts to scrutinize lab methods, chain of custody, and underlying assumptions. The bigger trend is a shift from forensics as magic toward forensics as one piece of a complex puzzle. Gunsmoke tests still appear in trials, but the legal system is being forced, sometimes painfully, to respect their limits.
Ballistics is bigger than GSR, and some parts of it are stronger than others. Matching a bullet to a specific gun using microscopic tool marks, for example, has more robust foundations than many people realize, but it still isn't infallible. Trajectory mapping, bloodstain pattern analysis, and wound ballistics each bring their own strengths and serious limitations. The danger comes when experts bundle these methods together and present a polished story with far more certainty than the data justifies. A careful ballistician will talk about error rates, alternative explanations, and how many independent clues must line up before they're comfortable with a conclusion. They'll explain that no single lab test, least of all a Gunsmoke swab, should ever stand alone. When you see forensic work that acknowledges doubt and complexity, you're usually looking at science. When you see absolute confidence from messy data, you're usually looking at persuasion, not proof.
Public perception is a huge part of this story. Decades of crime dramas have trained us to expect quick tests, clear answers, and computer screens that flash "match" in big green letters. Jurors walk into courtrooms with what researchers call the CSI effect, an inflated belief in forensic technology. Prosecutors may lean on that, framing GSR as a clincher. Defense attorneys then have to swim upstream, explaining why a positive Gunsmoke test doesn't equal a confession. This mismatch between expectation and reality affects plea deals, verdicts, and sentencing. It also pressures labs to overpromise. The more you understand about the limits of ballistics and Gunsmoke testing, the better you can resist that pull. When you watch a show or sit on a jury someday, you'll know to ask, what exactly was tested? How was it collected? What else could explain these results? And what can't this test tell us, no matter what anyone claims?
So, where does that leave us with Gunsmoke tests? Properly used, GSR is a supporting actor, not the star witness. It can suggest that a person was near a fired gun, handled a recently fired weapon, or came into contact with someone or something contaminated. Combined with solid witness statements, coherent trajectories, and corroborating physical evidence, it can help refine a theory, but on its own, especially when collected late or in contaminated settings, it's weak, ambiguous, and easily misinterpreted. Investigators who understand this treat GSR as a lead, something that nudges them to ask more questions, not something that hands them answers. The best crime labs document conditions carefully, test multiple surfaces, and are brutally honest about uncertainty in written reports. When all of that happens, Gunsmoke tests become useful tools instead of dangerous props in courtroom storytelling. Let's boil this all down into a few key points. First, Gunsmoke and GSR tests detect particles, not actions. A positive result doesn't prove someone fired a gun, a negative result doesn't prove they didn't. Second, distance and direction can sometimes be roughly estimated using residue patterns, but never with the pinpoint precision TV suggests, and never from GSR alone. Third, contamination and transfer are huge problems. Patrol cars, handcuffs, clothing, and even crime labs themselves can move residue around in ways that confuse the picture. Fourth, courts are starting to recognize these limits, but outdated beliefs and the CSI effect still hang over many trials. Finally, good forensic practice treats GSR as one piece in a larger puzzle and is upfront about doubt, error rates, and alternative explanations. If you remember nothing else, remember this. Real science is cautious, especially when someone's freedom is on the line.
If you stayed with me this far, you now know more about ballistics and Gunsmoke tests than most people sitting in an actual jury box. You've seen how a few microscopic particles can be turned into a dramatic story, sometimes accurately, sometimes dangerously overstated. Here's what you can do with that knowledge. First, be skeptical of any claim, on TV or in real cases, that treats a single lab test as decisive proof. Ask what else supports the conclusion and what the test can't rule out. Second, if you're fascinated by how science and law collide, this channel is where we dig into those clashes in depth. So if you found this helpful, hit subscribe, tap the notification bell, and share this video with someone who binge watches crime shows. Drop a comment with another forensic topic you'd like unpacked, and I'll see you in the next investigation.